Hello everyone, good afternoon. Hope everyone is doing fine. So I still see that couple of more people needs to join in. Only 90 people have joined in. So I'll wait for next 5 to 6 minutes. So everyone joins in and no one misses the code walkthrough. We're going to start with the code walkthrough first. And prior to that, I will discuss the evolution of entire convolution neural network and some pre-trained model. So I request everyone to please join in fast. Please inform your colleagues, friends, and other fellow professors, sirs, and madams to join fast so we can start session on time. Yeah, good afternoon, Vani sir, Vani ma'am. Good afternoon, everyone. Good afternoon once again, and welcome to the session of computer vision and NLP. Hope you guys have enjoyed already 2 days of session. So today's session going to be very exciting. So I don't want anyone to miss anything. So I request everyone again to please join in fast so we can start the session. Amar, can you confirm that I am perfectly audible and my screen is visible?
Yes, because you are audible and the screen also visible perfectly.
Yeah, thank you, Chandra. Thanks for confirmation. Hello everyone. Good afternoon once again. So I request everyone to join in fast. So still I can see hundreds of more people are missing. So whoso are not joined in, please join in fast. We're going to start session in 2 minutes. So I don't want anyone to miss anything today. So we're going to start with very interesting topic today. So I request once again all the respected faculty members, students, all the respected sirs and madams, please join in fast so we can start the session immediately. All right, I think we can start now. Most of them are joined in. So without wasting much of time, so we can start today. So guys, give me confirmation if everyone is settled down, everyone is ready. Most of us are joined in. So can you guys, a couple of you, if you can give me a go ahead, we can start the session now. Okay. Yeah, a couple of more people, please, if you give me confirmation, we can start. I hope everyone joined in. Yeah, okay. Thank you, Satya sir. Thank you, Vani. K. Vani. Thank you, ma'am. Thank you, sir, ma'am. Taranpreet Singh. Thank you. All right. So, guys, I'm getting confirmation, a lot of confirmation now. So, thank you very much for your kind confirmation. So, I think we can start now. So, guys, if you have questions, any queries, please let me know. Simultaneously, I will try to take the questions from this chat box. Okay, so you can post some queries, questions, your concern in the chat box. We'll try to solve simultaneously. All right, then without wasting time, let's get started. So guys, first thing first, so we going to understand first. So we were able to understand entire operation that first we started with understanding what is computer vision. So what is convolution neural network, how the human vision works, how computer vision works. Then we try to understand what are the difficulties, what are the major tasks performed by computer vision, and what is the benefit why computer vision is important. So then we started to understand from graphical point of view also, and from mathematical point of view also, so how the convolution neural network works upon. So this is what we were able to successfully see. And then we entirely discussed the entire architecture. So whenever we pass any kind of a image, whenever we pass any kind of image, what's going to happen, like how the layer by layer that is get convoluted, what is the convolution block, how it is getting getting here into the flatten layer, how it is getting into the stacks, and once it is able to stack everything above each other, then it will be passed on in the last layer. In the last layer it will be passed on, right, to the respective artificial neural network, and in the end we will able to get the output. We will be able to get the output. This is what we were able to successfully understand. And then we were able to understand like what kind of a blocks are there. These blocks, this is the entire convolution block, and then three operations are happening, which is conv operation, which is pulling operation, which is padding operation. Then it get flattened, and this is how the entire operations happen, and why we apply the filters or kernel, so-called kernels, and what kind of operation happen. This is what we were able to understand successfully, right? And this was the entire evolution, how the image is getting immersed through the layer by layer, how each and every layer is able to give us the entire understanding that what is read in which layer, right? Which vision layer working what, and how it is getting identified the entire image, how the entire classification works upon. So then we were able to understand this mathematically, all the three operations. So convey operation, then pulling operation, and padding operation. And then we were able to understand the visual layers, like visually how the edges are getting detected, how we combine the edges, the texture, pattern, color, and how the features appear. And once the feature appear, we can go ahead and try to convolute the entire image, and we get our bifurcation or get entire thing, entire stuff as a identification. So guys, this slides talks about the entire history, that how in history this entire thing is getting appeared, and how is entire thing started back in the history, right? So what was the first point of time then when this become entirely popular? How this entire thing started? So let's try to understand in couple of minutes like how the entire thing started out here, and what was the beauty, like how the things were started. Who was the first person to introduce this kind of a convolution neural network successfully? And then there is a series, entire series of the convolution neural networks which came into the pictures, right? So guys, convolution, you'll be shocked to know that convolution neural network exists from 1989, actually. The first multi-layer convolution neural network was ConNet, and which was developed by Jan LeCun. So Jan LeCun, if you guys already aware, I don't know, but there are guys three legends. There are three legends. These legends of AI, so-called legends of AI. And these guys, these legends, they have made a very large contribution in the field of the AI. The first one of them is Jan Lucan. Jan Lucan. So he's working as a vice president, chief data scientist, vice president AI in Meta company. Okay. And then the second godfather who just left the Google, he was head of Google Brain. He was head of Google Brain. Google Brain, which is entirely responsible for all the AI innovation in the Google. So he was a very, very favorite and esteemed professor, Jeffrey Hilton, and he left recently in the 2023 only this Google because of the safety concern and ethical concern which he expressed for when this chat GPT kind of application become famous. And then the third person, Jan Lucan, Jeff Hilton, and the third person was Alan Karzeski, and he was a professor. His professor, never joined any company. He worked as a professor in the Department of Science and Computer Science in the University of Montreal University in Canada. Okay. So these are the three legends. These are the people who made a major revolution in the entire AI industry. And after that, many people came in, they started to follow them, and that's how they came up with the different models. And nowadays, whatever innovation you guys are able to see, that entire innovation is possible because of these colleagues, okay, because of these legends. And these legends, they got the Alan Turing Award for their major contribution in the field of AI. These guys got more than like $10 million. $10 billion they got for their contribution, equally distributed among them for their invaluable contribution in the field of AI. So, guys, this guy, the legend which I am talking about, is a Jan Lucan. Jan Luca. He is the first one. He is the first one to introduce the convolution neural network, which is actually made some kind of a effect, which has proved us that this kind of a convolution neural network CNN architectures, if you develop them, that will be able to do a amazing job, amazing job. And what was the neural network introduced in 1998 was LeNet. The name was LeNet. Now this architecture, if you are able to see here in the bottom, this is called as a LeNet architecture. And this LeNet is totally pre-trained. And try to understand what is the objective this LeNet is able to do it is this way. If we could understand what is this LeNet and what was the contribution, what was the major contribution did by this LeNet was, try to understand in this way. This LeNet was the first working model, and which was able to show that if we are passing this kind of a handwritten digits like this way, if I am writing something on the paper this way, handwritten digits, if I write 0, if I write say this way 9, so it was able to and able to detect the images for the digits handwritten images from 0 to 9, 0 to 9. So this was the first case which was solved in 1998, and he had this 6 layers architecture. So six layer first convolution architecture, which is also called a LeNet, which was introduced by Jan Lucan. And this made an amazing breakthrough. This was an amazing breakthrough in the field of the convolution neural network breakthrough, and it became very famous at that time. Very famous at that time. Okay, and then try to understand what was the architecture. Since I told you that it was able to detect the handwritten digit recognition. So along with this Jan Lucan, there were two more colleagues were there, and they were able to understand this. And this is how it looked like. Let's imagine you are writing some number and passing this. Okay, so it consists of the 6 layers. Try to understand what was the 6 layers. So there was very famous question you guys were like asking me, that how to introduce number of filters, how many filters should we introduce, how many times we should do a convolution. So for that reference, this guide made a trial and error, and they were able to showcase us that within only the 6 layers of the architecture, they're able to perform this kind of a beautiful recognition of the hand digits, and then many more models came in. We'll try to discuss about this model. So let's try to understand what was this model and what was it was able to achieve. So we told that it was able to achieve the 9 classes, not nine, actually 10 classes from 0 to 9. The 10 class classification was able to achieve, and this had a 6 layers. Try to understand. They passed an image first year, which was the size of 32 into 32. 32 into 32. Let me change the color here. And then once they pass this image out here, once they pass the image, what they are doing is In layer one, they are applying 5,5 filters, size of 5 by 5 filters, or you can say kernels. So they are passing the 5 by 5 kernels on the image of 32 into 32. 5 by 5. And how many such kernels were applied? How many such kernels? There were 6 such kernels were applied. 6 kernels of 5 by 5. And stride, if you remember, I spoke about the stride, like how to move. If this is my entire picture, then if I am applying these kernels out here, then how to move that entire kernels or the filters around the image on the entire image, right? So that was one shift, s equal to stride equal to 1. That means it was able to shift one by one, one by one. Okay. So this is what they did in the first layer. So in layer one, they applied 6 such filters of 5 by 5. Then what they did, immediately after they applied this, they were able to extract some feature. They were like whatever filter was applied, they were able to extract out of that at least some features, some features. And that was such 6 kernels were applied, right? 6 kernels were applied. And immediately, once they apply, or what is the next task we do? What is the next task we do is we try to pull out the important information, pull out, let me rub these things. And that is why in layer 2, if you see that, they did a average pulling, and for that pulling also they decided a 2 by 2 filter. For using 2 by 2 filter, they did a average pulling. Average pulling. So by using average pulling, they were able to extract a few more important information and stride equal to 2. And then guys, again in layer 3, this was layer 2, and in layer 1, they were able to apply 5 by 5 filters, 5 by 5 6 kernel, which was a convolution operation. All right. And then again, they applied, then first they applied 6 filters, 6 filter of 5 by 5. Let me dark it in dark color. Let me rewrite in bold color so you guys can understand. And then they did a average pulling 2 by 2. And layer 3, in layer 3, again they did a convolution operation. What this time? This time they applied 16 colors, 16 such kernels were applied of same size. If you remember, or if you try to achieve, or try to go through it carefully, everywhere their kernel size, they are not changing. They're keeping constant kernel size, which was a 5 by 5. Only the numbers are changing, like numbers. First they applied 6, then they applied 2 by 2 kernels, 2 by 2 average pulling kernels, pulling kernels. This is convolution operation. And again they applied 16 such kernels, 16 5 by 5 kernels again at a second convolution operation. And again that was followed by 2 by 2 average pulling of stride 2. So this was what happened till layer 4. This was like this one, layer 1. This was layer 2, and this was layer 3. And in layer 3, guys, if you see here, they were able to achieve most of the features, In layer 4, again, they did a layer 4, they did average pulling. And then in layer 5, it was a fully connected. This was layer 5. It was an artificial neural network to which it is connected. Before that, they did a flattening operation. Obviously, they did a flattening operation. And in layer 5, they introduced a convolution artificial neural network, which has a 120 neurons, 120 neurons here, 120 neurons. And this was the input layer. This was the input layer. It was able to accept 120 neurons. And then guys, then it was able to followed by the hidden layer of 84 units, 84 units hidden layer. And then output, obviously, I told you 10 class classification, whatever digits are there from 0 to 9 handwritten digit, they were able to identify. So in the end, they were able to achieve the 10 class classification. And what was the entire show was all about, that they were able to explain to the people using the LeNet that within the only 6 layers, layer 6, they are able to achieve this kind of a high accuracy with such a good speed, right? Such a good speed. And this was the entire all about the first evolution of the first model. And this model was pre-trained. The model was pre-trained on the handwritten digits, like they used thousands of images. They trained it for the months and so on. And then it became very, very successful. This was the first point where they introduced the entire working of the CNN architecture, which was perfectly working. So this is how it started, LeNet. And then there was a famous architecture which was like 1,000 times faster than this LeNet, which was LXNet, which was one of the famous esteemed professor, AI legend, Jeff Hilton. He introduced along with his colleagues. This AlexNet. And then I will also show you this architecture, because if you try to, then guys, before we try to show this architecture, then there are many operations happened, and many models were represented, many research papers were presented. Like if you see in 2012, this was introduced after that, 2012, and then from 2014, 15, 16, 18 till 19, 20, and even recently in 2023 also, they came up with the various models. I will speak about this object detection models, and they will try to talk about this YOLO model, which is object detection, image classification, segmentation, everything. It is a multimodal model. It is multimodal model. So means it is able to achieve classification, it is able to achieve the pose estimation, it is able to achieve the segmentation, it is able to achieve the tracking. The entire thing, entire advanced thing they have introduced till 2023. Also, there are major research paper has been published. So try to understand this. One of them will try to understand. So try to understand. These were the major breakthroughs which was introduced by the Jeff Hilton in 2012, and then Google also introduced their own architecture, Google Net, then VGG's Visual Geometry Group, and then there was like series ResNet. ResNet has entirely different architecture, though it is a convolution neural network, but they have a something called as skip blocks. And this ResNet is not only small architecture. Let me tell you, this ResNet comes with a different architectures. So this was where this AlexNet was also having around 8 layers. This was having 6 layers, and this Google Net was having around 16 layers. VGG was having around 16 to 20 layers, and then this DenseNet and ResNet, guys. And then was also one InceptionNet. InceptionNet was also famous because along with the normal convolution block, they created this entire some other parallel blocks for the convolution. That kind of architecture they created, and they were able to understand if I parallelly also stack some of the convolution blocks, it will start working very, very good. Okay. So that kind of a innovation they did, like they try to do a trial and error, how I can arrange these architectures like this one. How can I arrange them? Can I put it parallelly out here, some blocks, or can we go in the depth, or can we increase the layers? In ResNet, guys, if you will be shocked to know, ResNet has various variant 50, ResNet 50, ResNet 100, ResNet 120, and ResNet 150, ResNet 250. They have created such a large depth of the model. There are 50 layers, 100 layers, 120 layers, 150 layers, 200 layers. So they did all kind of experiment, and the huge data set for one image category, they were for one category, they were able to provide the entire 10,000 data sets. And there they had this standard data set like the MS Coco data set, then ImageNet dataset. Then they have the CFAR dataset, Canadian Institute for Research and this facility. Then one more name, this COCO dataset, ImageNet dataset. ImageNet is a standard dataset which comes with the ImageNet competition every year. And this model, this AlexNet model, was a winner at that time for this model. This model was a winner of this competition, and this was very, very famous, which was 1,000 times faster than this LeNet, right? So this kind of architecture started coming up, and these all are, what is the beauty of this? They are all pre-trained model. You can use this model. You can directly use this model, and you can download this model, and you can customize them. You can customize this model for your own category or your own data. Okay, so that is why we are trying to talk about this. That's why I'm going to show you today one code walkthrough where I'm going to take you through the customized model of VGC 16 or something like that, and where we can apply our own custom data. All right, guys. So this is the entire history, how the thing started. They tried to do across the depth, across the width, all kind of experimentation they did, and they were able to achieve the accuracy along with this. And this is how the AlexNet look like. And this was only having the difference they were having also about the kernels. So instead of 5 by 5, they applied the 11 by 11 kernel in convolution layer, and 5 convolution layers like this one they did, and it was followed by this fully connected layer artificial neural network. Okay. So this is what the AlexNet was look like, and this was our LeNet. And here they were able to achieve. This was trained on the ImageNet dataset, which was a large data set. And here they were able to achieve the 1,000 categories. You can say 1,000 category classification image into the 1,000 categories. So 1,000 class classification they were able to achieve. So it was a very, very beautiful model at that time, and they were able to make a major breakthrough. All right. So everyone understood like how the evolution started, and this is the entire list now. This is the entire list is available. So how the entire things look like, and what are the convolution models available in the market out nowadays. And there is, this list is just a simple selected list, but there are many models available which you can customize. You don't have to create any architecture from the beginning. All right, guys. So I think everyone is now understood what is pre-trained architecture, what are the architecture available, how they did the experimentation. And like, I think most of you are able to understand now how to apply kernels, what length we should take, how many times we should apply the convolution block, right? Because you can see here, these people started with the small things, and they went to a large depth also. And according to the business situation, according to the business problem, according to your category, there are models available. You don't have to create anything. If you want a large model, that large model is also available. ResNet, 100, 150, 250, Google Net, BGG Net, Reception Net, Inception Net, Google Net, AlexNet, right? LeNet, all small architecture to big architecture. Every architecture available. You just have to download them, just that are available in their official website. You just download them, try to customize them, and try to work on them. Okay, because to be honest, it is not possible actually to scratch from the scratch develop everything. Okay, it will take months, years. They have invested their 6 months, 1 year to perform this kind of architecture, like what kind of a error model you should take, what kind of a classification error you should take, what kind of activation function you take, what kind of a kernel size you should take by layer. Should I increase the architecture, or should I decrease the architecture, or should I increase the kernel size, should I increase the kernel number, what architecture should I choose? That kind of experimentation they have done, and then they came up with these models. Okay, so this is not a simple answer like how many layers I should choose and how many experimentation I can do. So that is like it takes months and years to understand and to play and plug with it. So that's how nowadays everyone goes for the pre-trained model. So why to take much pain? Because we already have an innovation, we already have this research paper where thousands of models are available which are pre-trained. We can directly customize them. Okay, that's how in the industry everyone try to customize the model, guys. All right. So any question as of now, guys, before we start making a code walkthrough? Any question, any doubt, like what has to be done and what not to be done? What do we mean by this pre-trained model? What can we do with this pre-trained model? I hope now I am able to answer everyone's question, that how many layers should we take, what layers I should take, what things I should do, how to do experimentation, why to do experimentation, is it possible to do experimentation, how to build the models. Yes, sir, Bhai Kumar, sir. Yes, we can change the predefined model. I will show you now currently. I'll show you like we have to freeze the layers. We can freeze the layers, and then we can customize our data. We can change layers also. I'll show you today. Today is going to be very, very esteemed class, very interesting class today, because after code walkthrough, I'm going to start with this YOLO model, latest model, YOLO NAS, which was recently released in month of June. All right, guys. Apart from that, any other questions, doubts, please let me know. Okay, guys. So let me start actual code walkthrough now. So without wasting much of our time, so let's focus on this code walkthrough. Let's go to this one and try to understand. Just give me a moment. Let me share my screen with you guys so we can start understanding this one. Okay. Just a moment. I need to adjust my screen. All right. So guys, let me share my entire screen only. So it will be easy for me to switch between the screens, and I can show you the entire data and everything. So guys, can you just give me confirmation that you are able to see my entire screen? Just give me a couple of people, give me confirmation so we can start a code walkthrough. All right, thank you, sir. Thanks for confirmation. So guys, like I yesterday, I think already I shown you guys what is the data set is all about. So let me show it to you back again once again. So guys, this is my data set. Like I told you, we are taking two category, very simple category we are taking. But you guys will be asking me that why we're taking with this simple explanation. Because once you are able to understand how to create our own architecture, now we are not using any pre-trained model. Okay, try to understand this one. We are whatever data we are using out here. Like let me tell you. So whatever these categories we are using, this 10,000 images for cat, 10,000 images for dog we are using. And I told you like we are trying to take various conditions, various categories, from ugly dog to all the beautiful dogs, to all the categories, all the breeds, all lighting conditions, inside home, outside home, inside the garden, inside the cannon, whether they are sleeping in the dark room, all kind of a condition you can say, behind the bars, even within the canine, in the kennels, and everywhere we are taken all possible conditions. Okay, so our model will be able to understand the things. So this is what we have done for 10,000 categories for the dog and 10,000 such pictures for the cats for all the conditioning, all the categories, all the breeds. Okay. So then see, after taking 20,000 such images, we were able to take our even for test also the very huge data set, which was like 2,500 each per category. That means in total, guys, in total, we have taken 15,000 images, 15,000, which is a huge amount. So what is the beauty? Like what we have to understand whenever we trying to train this kind of a deep learning models, this kind of model, it requires a huge data set. It requires a huge data set that is not easy. That is not easy to collect this kind of a data set, right? That's why people are scared, like how to train this kind of a model because it requires huge input, huge computations, and huge power of GPU and TPUs. Okay, so that is the very costly affair, and that is not a everyday job. So that is why people go for the pre-trained model. Now I am showing you like if I want to make any model and I want that model to be kept as a let's say standardized model, so anyone can use it, customize it. That's how I am showing you first time. Whenever you want to do a research, all right. So everyone now aware of what is the data set. Let's start the code walkthrough without wasting much of our time. So let's do this thing. Which model can be used together to get a hybrid model to attain good accuracy for detection and medical imaging? All right, sir. I will tell you medicine only. So what happens, Gopal Saxena, sir? We have to take the latest model. Like when I'm going to discuss this YOLO model, at that time I will show you the comparison, sir. So I will show you the comparison, what are the latest model and how to choose those models. Like it is based on the FPS, like frames per second, and the accuracy, like major accuracy. What is the mean accuracy we are getting? Okay. MAP, it is called as mean average precision, MAP, and FPS. These are two parameters on basis of which we have to choose like which model is performing better, and then we have to showcase. I'll show you an entire list like when we going to start this latest YOLO model, which is a very famous model, which is recently introduced today in 2023, this year only, not today, this year only. So I'll show you, sir, like how to choose the model, from where to choose the model. So let's first try to understand if I want to create my own models, okay, my own architecture from the scratch, like how to create that. That's why I've taken very simple two-class classification. Then I'll show you how to customize the same model, pre-trained model for your face detection. Like you can take a faces of any people and can make a this kind of a detection. So guys, try to understand. Like I am trying to download first here the data set. Link is already given here. So data set link I have given. Kaggle data set is there. And then from there, I am creating one kind of a directory out here. So simply try to understand what I'm doing. This is my collab notebook. This is my collab notebook. Here in the collab, I'm going to create one folder first. mkdir. Okay, what I'm doing is mkdir, then Kaggle. The directory name will be Kaggle. Then I'm changing my directory to Kaggle, current directory to Kaggle. Okay, this is working directory. There will be one directory created. Now I'm not going to run each and every cell because it will take only half an hour more to run everything. So I have already run this and I will show you the result. You can try on or your own once it is able to understand this entire code. Okay. So once I have created this directory, what is the next step I'm going to do is in that directory, guys, I'm going to download by using this command Kaggle download dataset minus D. So this is command Kaggle dataset download minus D, and that entire dataset I'm passing out here. So once I am able to execute, see here, I have already executed this command. You can see it is started showing you. It is downloading the doccat zip file, okay, and then it is 100% complete. Once it is complete, obviously you are able to see that what is my problem now. So it is a zip file. It's a zip file. Now I have to unzip it. Unzip it. Let's try to understand how to unzip it. So import this zip file function, and from zip file you just pass this zip file dot zip file and pass this picture. This, if you try to go here, this folder will be Kaggle folder. On this there will be such three dots will be shown. So go to three dots and try to copy the path. Try to copy the path. That's it. Once you copy the path, you will get this kind of a path out here. Okay, that's what I've done simply. So I'm just passing this function my path of the zip file, and then I'm giving second command, which is zip dot extract all in the content only, in this folder only, current folder only. Okay, so that's how I'm doing. And once I am able to do it, that's it, guys. I'm able to download. Now next task, what I have to do. Okay, next task, what I have to do, try to understand. First, I told you guys that we're going to work. We are going to work with the certain packages now. Now here I am using the packages which are developed by Google. Okay, one is TensorFlow and one is Keras. Keras. These are the two frameworks which are developed by Google. Now when we now post second session today, when I'm going to talk about YOLO, if this YOLO framework uses the PyTorch. This PyTorch is based by the Meta, Facebook. They have developed the framework, and that framework will use. So you guys will be able to understand. These are really two famous frameworks. So whenever you are learning with a deep learning model, computer vision model, recurrent neural model, or artificial neural network model, these are the famous two frameworks. One is TensorFlow Keras, and one is PyTorch. So these are mostly used. Okay, so try to understand both of them, like how to import and how to use the functionality out of them to scratch from the scratch how to create entire architecture. Okay, so let's try to understand, guys. Let's try to focus out here what we have to do now. So first thing what I have to do is, in the background I told you that they are using TensorFlow, and the foreground, like which is like high level API, is Keras. Keras. Okay, so what happens is in TensorFlow also you can do a coding, but that coding has certain kind of a syntaxes, like you have to call the TFFlow session, then within the session you have to write the classes, you have to write certain things, you have to follow certain things, right? So certain way of the writing has to be followed. Then it will try to compile everything, try to convert them into the tensors, like n-dimensional array, and then it will try to process everything. That is the entire lengthy process. That's why people follow the Keras. Okay, Keras application out here. Keras is very simple, like the Python, you write, import the model, and you start writing everything. Okay, so that is why first I am importing TensorFlow, then I am importing Keras. And like I told you yesterday, this is a sequential. This is my model. This is the name of the model, sequential. So let it be any kind of a model, recurrent neural network model, let it be artificial neural network model, or let it be a convolution neural network model. For all the three categories of the models, we are using same model, that is sequential. Now you will be asking me that if I am using the same function, if I am using the same function sequential, then what is the change? Like how it is able to understand whether it is a CNN, RNN, or ANN by using the layers, guys. You can see here Keras dot layers. So this model gonna be common sequential, but the layers will change. Like dense layer, when I call dense, this is for artificial neural network. Dense layer. When I talk about convolution, pooling, flatten, batch normalization. Batch normalization and dropout is common for everyone because it is kind of a regularization. So when your model is not performing well, you have to penalize that model. So for that purpose, we are using that. So this batch normalization is for normalization purpose, like with the activation function, perform the normalization, try to bring the data into the lower scale. So we can do a batch normalization, like whatever features, like different matrices we are creating, it is try to normalize them into the certain scale. Okay, that is the batch normalization. So normalization happen across the width and across the breadth also. There are various types, like how it happens. So now, as of now, we try to understand there is a normalization. And the dropout is like they try to hide some neurons. Dropout means they try to hide some neurons, and then using that, they're trying to penalize the entire neural network. And that's how they try to achieve the accuracy if your model is not doing good. Okay. So these are the two methods to penalize the things. Then this is flatten layer, is like you know already in convolution, we have a flatten layer, pooling layer, and convolution layer, and then in between there will be padding layer also. I'll explain you. And this dense layer, when I talk about dense means it's a artificial neural network layer. And when I will use a recurrent neural network layer, I will write RNN, LSTM, all that kind of advanced model layers. I will write the name of those model. Okay, so try to understand, whenever try to develop a model using the Keras, we are always using sequential model, and the layers are changing now. So everyone understood what are the layers we are using now. Now try to understand whatever data I have selected here, whatever data I have downloaded, this 10,000 images for two categories, I have to create one data loader. So that data loader will take that images one by one, and try to load that to my model. Try to take from the directory and load it into the model. So that kind of a functionality I have to create. That is called a generator now. All right. So that is called a generator. So let's create a generator, one generator for training, one generator for validation. So how to write that? Very simple thing is there. You just write a name train ds, and then use this functionality keras dot utility dot image dataset from directory. Means it is just trying to take an image directory, that whatever directory we will be creating here, that directory it is trying to follow. So we just pass that the directory's path, and we are saying label equal to infant. Now what is why label equal to infant? Because whatever image we are passing, so it will be given names, right? Like this one. So if you try to understand, let me hide this one as of now. So let me go here. So if you try to take the pictures here, so let's imagine I am going to the pictures, and then you can see here, this picture is belong to cat, but we have written here cat 10. That means it belong to cat category. That kind of a labels they are talking about, right? So they are talking about this kind of a labels now. That is why they are saying label equal to infant means try to consider those labels, and then try to consider them as per that category. Okay. So that label equal to infant, then mode equal to integer, then batch size means take a 30 to 32 batch of each, and then try to load the data. And this is the image size, or whatever image size we have taken. That image size is given here, 256 by 256 images are taken. This size of images are taken. All right. So this is what I am passing, and same thing I will create for the validation data set. Same directory name, label equal to true. Then take the label's name and then take a batch size of 32 and take an image size of 256 by 256. And the moment I run, guys, moment I run, you can see here the result. It has captured 20,000 files for two classes for training and 5,000 files for this belonging to the two classes for testing purpose, validation purpose, right? So this is how I created my data loaders now. Now my job is to do a kind of a normalize, means whatever pixels values I will be having, some will have high pixel value, some picture will have low pixel value. I'm trying to bring them a normalize, try to normalize these values. So what I'm doing is I'm creating a simple function and using this simple function, whatever image is there, that is converted to matrix, and whatever matrix is there, the tensor, we call this a tensor. Whenever we have a created three-dimensional arrays, more than three dimension, we call them tensors. So not a matrix. So that tensor which contains multiple matrices together. So that tensors I'm taking that images dividing by 255. So it will become to a normal scale, normalization scale. Okay. So this is how I done for both the training and test data. Then guys, then this is my real architecture starts now. Okay. So my real architecture now starts. Try to understand this way. Label. Okay, okay, okay. I will repeat label, sir. Okay. So what do you mean by label? Try to understand here. So this label equal to means try to understand. Whenever I am loading my images, right? So I am loading both the images. But did I write anything here that only take from the dog folder, or did I take ask it to take from the cat folder? No, I am not writing. I am just writing 10 take from the train folder, take from the test folder. Now try to understand what do you mean by labels equal to info. So when I go to this one, let me hide this one again. Or should I take this down? Okay, it's better to hide this floating. Okay, now this is better. So let's imagine this one. So when I take a test folder or train folder, in that folder also there are two category of folders, train and dog and cat. But when I'm giving a path for the data loader, I'm giving only training path. Means what is happening, then it should be able to understand which image belong to which category. That's why we are given labels here. You can see cat 1 10,000, cat 10,000, 22, cat this cat. Every cat is given an image cat and followed by the numbers. So this is called as labels. This is called as labels. So I'm asking simply that please try to take, because I'm directly given a path. I'm not giving any path particular to any category, right? So that is why it will be able to understand that what that entire image I am taking, whatever image I am taking, that image is belonging to what category, whether that image belong to cat or that image belong to dog. So that is why we are saying take the labels given for that images and then try to infer them and try to understand them as a your category. Okay, that is what is labels is called as. Hope I am able to answer your question. And then guys, now try come back how to build our model now. So now we have to train from the scratch, right? We have to train from the scratch. No, 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 sir. Inferred is not a label actually. Inferred means label equal to inferred means whatever label is given to that dog picture or cat picture, we are writing cat, dog. So try to infer that means try to take that meaning. That's what we are calling that label equal to inferred means. Means whatever image name will be given, try to consider that image belonging to that category. All right. Now clear, sir? Okay. All right. So now guys try to understand that we are not using any kind of a pre-trained model here. We are trying to write everything from the scratch. Like I have to create my own architecture, right? I have to create from zero and I have to build my own imagination. Like you can call this as Vikas model, right? So like the godfather of AI created his own model by his name, LeNet, Jan Lucan. So you guys can call this as your own model, ExcelR model, Vikas model, or this your model, sir. So let's take the name anyone Abhay Kumar sir model. So you can say Abhay Kumar sir model, right? Abhay model, right? So and Abhay net, Vijay net, whatever guys. Okay. So you can call this as your model because this is your own innovation. You are own creator, right? Let's take this example. Okay. So let's do this way, sir. Try to understand this one. Now, how to build our own architecture, which can we can give our name, we can publish this even. So if you try to test this with the ImageNet data set, Coco data set, and if your model is able to achieve that kind of accuracy and the speed, we can publish this as a paper also. And you can write that for what purpose. Let's someone was asking, some sir is asking like how to create a model, which model should we choose for medical imaging. If you are able to present a use case, like you train this model, let's imagine this way. As if someone is having a cataract in his eyes. Cataract, right? Everyone understand cataract. So before cataract, like your eyes will start getting some kind of a curtains. It will try to lose the entire clarity of the eyes. So you can create one model. I'm giving you one idea. So you try to pass like 1 lakh images for the eyes which is having cataracts, the eyes which is not having cataract. Okay. Now you try to benchmark that model and try to train this and try to create this model from the scratch. Benchmark that model with like thousands, billions of images and try to classify them and try to give them feed them of the eye, the picture of the eye, iris pattern. If I try to take the eyeball and a pattern of my eye, and then which eyes is belongs to cataract eyes and which eye don't have a cataracts in the right, that kind of a category. And you can create your own model. You can write a cataract model, right? You can publish that. Okay. So that kind of ideas can be done. Like people try to do this kind of a different innovation. They try to arrange the model in the architecture and they try to showcase them like how it is working. Okay, so that kind of a thing we're trying to approach. I'm sure you guys will be laughing on me, like, but this is how the thing starts, like for the research. Okay, for the research, this is how the thing starts. And the slowly you guys can gradually understand the very important topics and you can build a model around it. So let's try to understand. I'm building just a simple two-class classification model. Let me give any kind of a class. Let me give only two categories and you provide two category picture. This model will be able to identify that pictures. Okay. So that is what this generalized model is all about. So now try to understand first thing, how to build a model. Okay. The first thing what we have to do is we have to call a model our model. I told you sequential model we are using. Let it be convolution neural network. Let it be artificial neural network. Let it be recurrent neural network. We will always, whenever you are using Keras, you always use this model. Model equal to sequential. Only change is guys in layers. That whatever layers you are using, as per that layers, it will try to work. Okay. Now, since I have to create a convolution model, so I'm calling this model. Then, guys, then I am going to create here 3 blocks of convolution. Remember, I told you guys that when we try to pass this picture, right? When I pass this image, it will go through 3 steps, right? First will convolution block, and then after convolution block, there will be flatten layer, and after flatten layer, there will be artificial neural network, like this one, artificial neural network, right? So these are the 3 important steps. Now this conv block, this such block, conv block 1, I am going to create 3 such conv blocks. Okay, conv block 1, conv block 2, conv block 3. And within all these blocks, the same operation will be happening. That convolution operation which we talk about. Then second operation will happen, the pooling operation. And the third operation which will happen is the padding operation simultaneously. So all these 3 operation is called, entire operation is called one block. Such 3 blocks I am creating, then it will go to the flattening layer. Then it will go to the fully connected layer. It is called as fully connected. And then in the end, we'll get our predictions. We'll get our prediction like class 0 or 1. So 0 will belong to cat and 1 will belong to dog, guys. Okay, we'll try to perform this kind of a prediction out here. Now I'm going to create 3 such blocks. So this one, let me rub this thing. So these 3 codes, first 3 line of a code. This is my convolution block 1, convol block 1. So same code I have copy pasted, same code I have copy pasted, nothing, only one change I have done. I'll show you. Same code I am copy pasting everywhere and only one change I am doing. So this is block 3, this is block 2. Now try to look at the change what I am trying to do and I will explain you what the change I am doing. If you see here, first line, what I am talking about is model.add convolution 2D. I'm adding first convolution operation 2D, like I told you, right? So if your picture is 2D or 3D, like you can add conv 2D, conv 2D, or you can add a conv 3D operation also, 3D filter, right? This is what we are talking about. So I am adding 2D now, as of now, 2D picture I am adding. So try to understand this one, this code, okay? So I am adding convolution 2D. Now, if you see number of filters out here, I am first writing 32 filters. The kernel size is 3,3. Kernel size is 3 by 3. 3 by 3 kernel size I am adding. And every layer I am adding padding equal to valid. Padding equal to valid means add a padding layer. Add a padding layer. So once I perform a convolution, immediately add a padding. Immediately add a padding. And then this is 3 by 3 filter I am passing. And such 32 filters I am passing. Such valid means yes. Okay, valid means it is trying to add a padding layer there. Valid means whether you want to add a valid padding layer or not. Okay, valid padding layer or yes or no, like that kind of operation. Valid means it is adding a padding. Whenever we performing this convolution operation, it is adding padding also. Means it is gaining back its operations. Okay, 0 or 1 or same. It will take by default, it will take like same. By default, it will take same, but you can have other parameters also to apply that. It will have some by default value, okay? That way. So now try to understand. Okay, thanks for question, sir. Very nice because I was also able to explain to the people like what is happening. Thanks for the question. Okay, guys, now try to understand what is happening. So what I am doing is this is my first block, okay? In first block, I am first adding my convolution operation, convolution 2D. I am mapping number of 32 filters which are of having size kernel size 3, 3. Then I am taking padding also equal to valid means please also do padding after that. And then I am writing my activation function relu, activation function relu. And when I write first time, when I write a first time this layer, that time only you have to write a input size, input size. So I remember, if you remember, our input size was like 256 by 256. 256 by 256 size into 3 because it's a color picture. So first time only you have to write input size, otherwise you don't have to write the input shape, okay? So this is what I have added, right? So now this is my convolution layer. Then immediately after that, what I'm doing? I'm doing batch normalization. If you don't want, you can like remove them, make them hashtag first. Try to go for normal one first. Then after that, I also add a batch normalization if you want. Try to do experiment, guys. I'm trying to tell you that I try to do the experiment. The first thing what I'm trying to do is I'm just adding first convolution operation. Within that, I am adding padding operation. And first time, since I am writing first time, I am writing my input size also. What is my input size of the image? Okay, first time. And then I am adding padding. Then kernels are 3, 3, and such 32 kernels are taken. Okay. Then batch normalization, I am added batch normalization here. Then I am doing pooling, guys. Max pooling. I am doing max pooling. Pooling size is 2, 2, and stride is 2. Padding is also valid because after pooling also I am doing padding. Okay. So this kind of a safety layer. So I do not miss the information. This is a style, like how you should write. Okay. You can follow your own style also. You don't want padding, you can remove also. You try to do the way you want the experimentation. So now for the safety purpose, we are doing this one. Now guys, once I am created this block one, same thing I copy pasted out here, but only change. If you see only change, let me show you the change. What I have done, I have increased the filters. I have increased the filters here. 64 filters I have taken. The size is same, bash normal is same, pulling is same, everything is same. Okay, everything is same, and but only thing is change is number of kernels are now increased. Size is same also 3, 3, but the kernel size is changed. Okay, 64. Then same code I copy pasted again. Same code copy pasted. Only now I am changing more filters. So first I took how many filters? First I took 32 filters. In block 3, I took like 62 filters, 64. Sorry, means I am making double. I am doubling the filters, and then I am taking 128 filters. 120 filters, and filter size are same, like 3 into 3. Now there is no logic. There is no logic. So you might be thinking that what is the logic I am trying to double? Only thing is I wanted to go to the minute, deepest level of the features. Okay, deepest level of the feature, and after that I want to remove the duplicates and clean everything. That's why I'm doing pulling, max pulling I'm doing. Okay, maximum pulling I'm doing. So that is the reason. Okay, that is the reason I'm doing this kind of a things now. So you can write our own filter size. There is no such problem, no such problem. You can write any kind of a operation, any kind of a filter you want. I suggest everyone, please try to change this kernel size. Please try to change the number of filters. Please try to play with this padding and all. So please try to play with the activation function. Okay, so you can do that. What kind of a padding is valid? Okay, padding by default that takes some padding, like it will try to take the same padding, but I'll explain you like later on what kind of a padding it takes. By default, we'll try to search this by default value. What is the by default? What is it taking? And then I'll explain you later on. So by default, there is some mention like whether it is to take 0, 1 or same padding. Most probably it take the same padding if you don't make the recommendation. But we'll try to search later on. Like I will explain you later. I'll give you this answer. What exact padding they will take. Okay. So guys, this way I've created my 3 blocks, convolution blocks. Now simple. Then after that, I have to do flattening. Model dot add flatten layer. Model dot add a flatten layer, and that's it. Once I add my flatten layer, so I think everyone is comfortable till now. What we have done, we have added 3 such convolution blocks. Then I did a flattening operation. Okay, let me rub this thing now, and then let's go back and then let's try to go ahead and try to understand now what next thing I'm doing. Now once this is the architecture I've created till now, you can see here we have created these 3 blocks now. Convolution block 1, convolution block 2, convolution 3. Every layer has a pulling, every layer has a pulling, every layer has a padding, then every layer has even activation function. Every layer I have created a bash normalization, and every layer has a convolution operation. Such 3 layers are created. Then I am doing a flattening operation here. So this is the code for flattening operation, model dot flatten. Model dot add a flatten operation. So this whatever features will be created like this one. There will be multiple matrices created end of this, because first I applied how many filters? 32. Then I applied 64. Then I applied 128 filter of size 3 comma 3, kernel size 3 comma 3, right? So they obviously this will create many features. So this will be stacked, and then I am in the end I am writing about this architecture, which is the artificial neural network. So try to understand this one, guys. All right. So I am adding first layer of the artificial neural network. That is why I am calling as a dense. Model dot add dense. Model dot add dense. 128 neuron I am taking. 128 means whatever neurons I am taking input size like this one. Such 128 neuron I am taking. Such 128 means it should be able to accommodate at least 128 such matrices. 128 such matrices of the feature matrices. Feature matrix. Okay. So that is why we have taken 128. Then I have taken second, and you can see here I have added dropout also. So initially, I would suggest don't take this dropout first. Okay, initially hash them. Don't take a dropout first. Only go for the normal thing first. Only go for normal. 120 features feed to correct, sir. 128 features feed to the neural networks. Okay, correct understanding. You can take more also if you take more, because why 128? Because you see here in the last size, last layer, you can see 128 minimum 128 features would be extracted, right? 128 such kernels are applied. That's why I'm taking 128. You can see here. So you can take less or more. You can try to experiment. Only thing will be the less or more features will be getting captured. Okay. So that is why. Okay. That is why we are taking like same kernel, whatever number of kernels I've taken, minimum that many dense layers neuron I've taken. That's why or at least whatever 128 created should go. Everyone should go here, right? That is what I'm doing. Then guys, I suggested don't go for dropout first. Go as a plane. Then you try to add a dropout if your model is not working good. Okay. Let me rub this thing down. So see here, first thing I have added is my 120 neuron activation ReLU. Then don't hash this first, try to run without dropout. Okay. See dropout. You can see here dropout equal to dropout. You can give anything between range of 0 to 1. Means if you give like 10%, 0.1 means 10% dropout. So 10% of your neuron like this one. If I display 100 neurons, the 10 neurons will be deactivated. This is what it happens in the neuron. Okay, this is how it is try to penalize. So that's why I'm saying first plain go without dropout, then try to add a dropout first. Okay, then I am hashing here. Just add a first input layer, then add a dense layer, 64 neurons, hidden layer, and then last layer is like 1. Because why 1? Now can anyone tell me why I have taken only 1 neuron in my output layer? Like in I have taken 28, in 64 I have taken. So I explained you the logic for 128. So can anyone tell me like why I have taken only one single neuron here in the end output layer? Output layer I have taken only single neuron. Can anyone tell me the logic like why we have to take only one? Why I have not taken 10, 20, 30? Binary class, correct, sir. Awesome. Binary class, correct. 0, 1. So we are taking 0 as cat and we are taking 1 as dog. Correct answer, sir. Correct, sir. Correct answer. Correct. Binary class, correct. Okay. So that is why I have taken single neurons. If this would have been multi-class classification, I would have taken that many neurons, whatever my classes would be there, right? So multi-classes. Okay. So guys, this way I created my own entire architecture. This way. Okay. 3 plus convolution blocks can be added. Yes. You can add any number of convolution blocks you want. Okay, but remember, if you guys remember, when this Jan Lucan, LeNet, when he introduced the LeNet, it only had a 6 layers. 6 layers. And the AlexNet, if you remember the AlexNet, here he did at least 10 class classification. 10 class classification. AlexNet did 1000 class classification. 1000 classes were able to detect. And how many layers were there? Only 8. So if I am doing binary class, that is more than 3 blocks are sufficient, right? Flattening stacks layer used to store after applying. Yes, sir. Correct. Kumar Swami, sir, correct. Your understanding correct. This flattening layer, what we'll do is whatever matrix is created like this way, right? This way we'll create a matrix. So it will try to stack them together. Why stacking? Because that will go inside in our that will go inside our artificial neural network. Correct, sir. Stacking. Correct. It is going to do a stacking. Correct. Flattening means they are trying to arrange like one above another. Why one above there? Because I have to pass them to the neurons, right? And neurons will be like this way. So that's why every matrix should go into one neuron inputs. That's why you have to flatten them. Right, guys? So this is what I've done now. Now try to understand whatever things I've created now. I want to check whether everything is looking correct or not. So that is why one simple function is there, model.summary. Once you run this model.summary, you can see here. So it has first created this one first block. First block, you can see a first block 32 kernels, right? Bash normalization, convolution operation, max pooling operation. So all the 32 layers, this is created. Then you can see here second layer. Second layer, we have increased the filter from 32 to 64, right? And this is how. And you can see here in the parameters, you see here parameters. What is this parameter? Why sigmod is the output layer, not softmax? Okay, okay. Why sigmod in by because try to understand, sir. So yeah, not due to non-linearity. It is not due to non-linearity. There is a reason like, but non-linearity will come in the hidden layers. You can output layer in output layer. If you have a binary class, if you have binary class, then they use a sigmoid. They use a sigmoid. And if it is a multi-class, if your output is multi-class, then they will use a softmax. Softmax or anything, because softmax function will try to take all the classes and try to bring them in the scale of 0 to 1. So whatever probability you will create, because if you use a sigmoid for multi-class, what will happen? Sigmoid will give you a simple probability like this one, 0.8, 0.7, and 0.10. And let's imagine you are a 3-class classification. What is happening here? 7 plus 8, this one 15, 15 plus 1, 16. Means I am getting 1.16 probability, 16, right? So this should not be incorrect. It is incorrect because it should be 100, right? Whenever I try to sum my probability, it should be 100. That thing is achieved by using softmax in multi-class. So whatever probability it will give, try to bring all the sum of the probabilities to 100 between 0 to 1 this way. And that's why if it is a binary class, we use sigmoid. Sigmoid will perform better. If it is not a binary class, then we go for a softmax. Softmax or soft plus or any kind of operations. Okay. So that is the reason. So activation will only happen, this activation non-relative will only happen hidden list. Okay. So guys, now you can see here last function parameters. Look at the parameters that it is generating. Means what do you mean by parameters now? Can anyone tell me? What are these parameters are shown here? 896, 128, 1000, 18,000. These parameters are generated, right? This is our block one. So this is my block one. This is my block two. You can see here, this is my block three, and there is a flatten layer also. You can see summary. And then there is a dense layer. Then there is a dropout layer, and there is another dense layer. Last layer, 1 neuron, 64 neuron, 120 neuron. So here 14 lakh plus parameters are generated. So can anyone tell me what are these parameters? What are these parameters? Why we are generating these parameters? What do you mean by parameters? What is happening actually here? Learned hyperparameters. You are close, sir. You are close. But can you like explain me mathematically like what is happening out here? What is happening actually? Can anyone tell me what are these parameters actually? Weights and biases, correct? Awesome, awesome. Weights and biases. So it's a waist color shape. Yes, yes, sir. You are close color shape, but weights and biases is correct answer. Like we have a weights and biases. Like try to understand when I create an artificial neural network. So it is not only weights and biases. Try to understand what I told you guys that this convolution neural network CNN, it is made up of two things. Okay, let's understand this one. Weights, correct, correct, sir. Kumar from sir, correct. Weights. And one more thing is there. You guys have forgot, I think, that this is connections. These connections are called as weights, right? And then we have a bias. Like our model is like this way: WX plus B, right? Weights multiply by input plus bias is B. So this is there, but you guys have forget that when we do a convolution, right? When we do convolution, CNN, RNN, three models. Yes, sir, there are three models, but here in CNN we are using CNN plus ANN. CNN use the CNN block plus ANN here. We're not using RNN anywhere here. Okay. So try to understand, sir. Try to understand. So this weights and biases is okay. You guys are giving correct answer. Now you guys have forgot about the filter kernel. I taught you that filters are taken randomly first. We're first taking random numbers. Then here it is try to learn the kernels and the filters. That is also important. So that is why these parameters are there. Okay. So that is what the parameters are here, guys. So these parameters, they are learning these filters. Remember? So when I am applying these filters, we are applying random numbers initially. Then it has to learn the exact filter, right? Exact filter which will be able to take number of filters and filter size. Correct, sir. So there is a weights and biases, and there is also filters which are applying in the convolution block, right? These things are become parameters. It has to learn these many parameters. That's why remember I told you it is a costly affair. Now look at the end. Look at the end now. How many total parameters, trainable parameters here? How much are there? Can anyone tell me? 6 digits, right? Like 7. 1 crore, 1 crore, 48 lakh, right? 1 crore, 48 lakh parameters. This many calculation it has to do. When I created just simple 3 blocks. So you guys were asking me, right? Why we are only creating 3 blocks? Why not go for more? Remember, that is the reason. You're creating 1 crore, 48 lakh parameters. How many time it will do to perform this calculation? How much time it will take? How much time? And now look at the things. We are training 10,000 images. Okay. So you guys were asking me what is the calculation? 10,000 images. Okay. Remember this one. 10,000. And tell me the calculation now. 10,000 images will get converted into 3 matrices. Correct? 3 matrices. So 10,000 into 3. What will be the number of matrix? Training data, set, weights, values. Correct, sir. Correct, sir. Kumar Swami sir, correct. Your understanding is correct, sir. So imagine this 10,000 images, like this is for one category, okay? I'm talking about one category. Actually, there are 20,000 images. 20,000 into 3. This many matrices will be created. Then we'll apply how many filters? 3 by 3 size filter, 3 comma 3 filters of how many? First I am applying 32, then I am applying 64, then I am applying 128. So if you count them and try to multiply them with each one of them, every image will be taken. Every image will be taken and they will apply this kind of a filters on them. They will try to learn. So you try to understand what kind of a competitions are happening. Huge competition happening. That is why we are taking very small network as of now. And we want to check our small network is performing or not, or you can check for other things also. You can increase or decrease the layers. Okay. Guys, now try to understand 1 crore 48 lakh parameters are created just by using only simple 3 blocks. 3 blocks and this kind of a neural networks, right? Simple neural network, 3-layer neural network I have created. So that's why, guys. That's how I have created neural network. Now, what is the next thing I have to do? So compile the model. Model compilation means pass the information that which optimizer you want to use. You guys already know optimizer. We have a different optimizer like Adam optimizer is there. So gradient descent is there. Stochastic gradient is descent. Stochastic mini batch. The ADA grade. There are different optimizer. What is the job of this optimizer? Guys, this, yes, correct, sir. Abhay Kumar sir, SDD, ADA delta prompt, RMS prompt, various optimizer there. This optimizer job is to reduce the cost, optimize the cost. Okay. And then we are doing binary class classification. I'm using that loss function, matrix equal to accuracy. So this information I passed, and that's it. My model is trained. Model.fit, pass the training data, and now I am writing the number of epochs means it will run for 10 epochs each. 10 epochs each. Okay. And within the 10 epochs also it will run multiple times because in the number of batches, it will take the data, right? It will take the 10,000 data in the batches. So I'm asking only 10 runs, and then validation data equal to validation, train data equal to train data. That's how my training is started. Now I running, then you can see here epoch started, and you can check the accuracy here. So accuracy for training is 60%, validation accuracy 63%. Now it is slowly increasing, 74. Now, and end of the 10 epoch, you can see your accuracy. Now check the accuracy here. What is the validation accuracy? 97, and this is 80, guys. 97, 80. Now what is the problem? Image size is given me in the code as 250, but in summary images. Okay, sir. Summary image. Because I have not rerun the code for different things. Okay, so summary image, it is giving. Okay. Because what I have done is like if you are able to see this one, I have not rerun the code. I have changed the code in between. Like when I have tried to showcase to the people, you can see here. Even the spelling is changed. So that's why. Otherwise, it is the same thing. Okay. I am multiple times running this code. That is why it is mismatching. Otherwise, everything will be same, sir. Okay. Okay, graph I will explain you now. Now I am going to explain you guys graph. Okay, sir. Now try to understand what is happening actually. When I train my model, you can check the accuracy. Training accuracy is 97 and validation accuracy 80%. And this is 97. So what is the problem? Can anyone tell me what is happening actually here? What is happening? What is the problem? Is it a good model or bad model? Can anyone tell me? My validation accuracy is 97. My test accuracy is 80. Overfitting, correct, exact. This is what I was looking, sir. Yes. So training versus validation, yes. Overfitting, correct, sir. So you can see here, training was 97, and yes, this graph is like same thing. It is trying to plot. I am trying to plot the accuracy of training and accuracy of validation, and trying to check. You can see here there is a huge gap in the accuracies of training accuracy and validation accuracy. This is the graph I am checking. Now, when you have this kind of a situation, That is called as overfitting. Then guys, then I am go back and try to introduce these dropouts. Then I introduce this dropout if you face this kind of an issue. Okay, add a dropout, then rerun. Now I'm rerunning, retraining my model. Now check the accuracy. Now this gap is closed. This gap is closed. It is like reduced right here. So after introducing the this kind of a dropout. So that is how I've shown you like how the dropout will work. Now you can check the gap has been reduced, right? So this is again a gap I'm plotting for the validation accuracy and train accuracy. Now it is reduced, right? Now they are close to each other, like somewhat close, not that close, but somewhat close. So now this is my better model. Now this is my better model. So this is a loss actually, and this is a loss after validation, after the dropout. Okay, loss has been also, this gap between the loss has also been reduced. So loss I'm checking accuracy in the above graphs, accuracy. Okay, train test accuracy, train test loss. And then in the end, I have I have written some notes over here. So what you can do is if you start to find this kind of overfitting, you can add more data. One thing is you add more data. Second, you do a data augmentation. Okay, data augmentation means try to copy the images. Accuracy based on graphs. Yeah, correct, sir. Accuracy based on graph means these graphs are showing the accuracies. Like what is the training accuracy and test accuracy? That is what we are trying to plot here and try to check if there is a difference or not. That is what I am plotting here. I'm taking training accuracy, red color, training accuracy, validation accuracy, and then I'm trying to plot and try to check like how the accuracies are going training testing. That is what I'm doing here, sir. And then second graph is for loss, like how the loss is going. Once it is a loss, you can see here, sir. So it is accuracy, then it is I am trying to check the loss function, how my loss is behaving. Okay. These are the two graphs I've taken. So now guys, I told you like if your model is overfitting, so at that time you can add more data, you can do data augmentation means whatever images you have, you try to create more image out of that image. Okay, using data augmentation technique. You can add as a regularizer, you can add a dropout, you can add like batch normalization. Remember, I shown you also normalization, and you can reduce the complexity of the data. And this way you can reduce this overfitting, whatever overfitting is there, like huge gap between training and validation. Okay. And now what I'm doing is several graphs, choosing graph with higher accuracy. Yes, sir. Correct. We can choose a higher graph with higher accuracy also. Like you can check like what is my main aim like. So I'm trying to take like graphs and try to do a comparison whether my model is performing good or not. That is one of the reason, and it is also like choose the graph which is giving high accuracy means go for that kind of a model which is giving high accuracy. Yes, correct understanding, sir. Kumar Swami, sir, your understanding is correct. Like this is what I am doing. Like I'm trying to find out various models and try to plot their graphs and try to check which one is giving better accuracy. Then try to check. Correct, sir. Thank you. Thanks for confirmation. Okay. Then guys, once I am able to do reduce this overfitting, then is obviously I'll try to check my model now. I'm reading one image from the Google and trying to upload here. I'm just downloaded one image, any random image, and this is how the image look like. Now try to test this image. So this image I have uploaded here and I'm trying to test this image. Now whether it is going to give us a correct prediction or not. And this is what I've done here. You can see here, I've resized the image on the shape, whatever input shape I've mentioned above. Remember, in above I have mentioned 256 input size to my model. Then this is the same thing. I've resized that image and then I'm trying to do a test. Model.predict pass this image now. So you see here, it is giving me accuracy as 0. Prediction as 0 means it is a cat image. Means it is able to identify correctly. It is a cat, correct? So if this would have been given 1, then there would have been a problem. Otherwise, the cat correct, it is given 0. So this how guys, this is how I have created a binding class classification. All right. So this I have shown you like entire working is like whenever you scratch from the scratch, how you're building, why to build, how many layers should be taken, try to look at the number of kernels, try to train the model with different sizes. You can check the parameters like how heavy your model gonna be if you add more layers, and then if model start doing overfitting like this one, how to handle the overfitting. So this is like corporate style. This is the entire corporate style model building. Okay. This is what is called as corporate style model building. All right, guys. So I think everyone is very happy. So to understand how to build our model from scratch, and you guys can give your name. Kumar Swami sir can give their name, Kumar model, and then Sir Swami model, Swami net, training data set to be represented in database, then comparison with the images. Yes, sir. Yes. We can do the same thing, or we can do we can do like a random testing also. You can do yes. Zero is for cat. Yes, correct. Based on the same thing. 0 cat. We have taken this data on 1 for dog. Correct. This is what we have set like the index. When you pass a folder, so if you pass a folder, if you keep a first folder as cat, then it will consider cat as 0, and then if you keep a second folder as dog, then it will consider 1. So this we have to keep it. Okay. Optimal value of dropout. Okay. Optimal value of dropout. Again, it is a hyperparameter. So what happens is like you cannot give a fixed value. You cannot fix value. The logic is here. You have to start with a small dropout. You have to start like 10%, 20%. You have to check the your performance of the model, like how your model is doing. If I add a 10%, 20% dropout, whether my model is able to reduce the overfitting or not. So this is nothing fixed. So it is based on the trial and error. It's based on trial error, or you can use a hyperparameter tuning model. Like Keras has a something called as Keras hyper tuner model. So you can use that, sir. Okay. The dropout values is, yes, sir. Correct. So dropout value will be always between 0 to 1, 0 to 1. Okay. Always 0 to 1. Because you can like take accordingly like how much percent of the neurons you have to deactivate during the training. Okay. That's how. Correct, sir. Correct understanding. All right, sir. So any other questions? And now you are able to understand. Everyone understood like how the entire things works. So can I make one more quick code walkthrough before we start our YOLO model? Because I have to start a YOLO model also. Yeah, okay. Thank you, sir. Thanks for confirmation. I think should not be one. So not sorry, sir. Can you like please explain, Abhay Kumar sir, about what thing you are saying? One dropout one. Okay. Dropout one means dropout one means dropout one means you are dropping out entire your neural network 100% dropout. So that is how dropout one means 100% dropout. So dropout one means 100%. Every neuron is deactivated. This will not work. Actually, you have to like half, like go for half, 30%, 40% neuron to be dropped out, right? So during that, that's how. Yes. Between 0 to 1 means you cannot take one. Like one will be like you are dropping out everything. So it's like yeah, they're trying to mention the range, like range. Like yeah, your understanding is correct. Like I can understand like what you are trying to express here. So I think you got your answer, right? Batch normalization optimizer. Okay. Batch normalization, yes, sir. Optimizer, I will give you a quick overview, sir. I will give you a quick overview. What is optimizer? Let me explain you the optimizers. Like batch normalization is like they are trying to like I will explain you what is batch normalization. Batch normalization means they are trying to optimize everything. Like I will tell you what is batch normalization also. I'll give you a quick overview, like what is this entire thing is all of the optimizers. First, let's talk about the optimizers very quickly. Optimizers means what? There are like different optimizers. Very famous optimizer is gradient descent. Gradient descent. Okay, gradient descent. That is called a GD, gradient descent. This gradient descent has three flavors. Like one is stochastic gradient descent. Stochastic gradient descent. One is mini batch gradient descent. Mini batch gradient descent, and then there will be normal gradient descent, standard normal gradient descent. There are three flavors, and then there is one more like Adam. Adam is adaptive moment estimation. Adaptive, adaptive moment estimation. Okay, then there is something called as RMS crop. There are various like optimization, minimize using back normalization. Optimization minimized using back, sir, not back normalization, using back propagation. They are trying to optimize using the back propagation. You can say, sir, Kumar Swami, sir. You can say like in back propagation, when we do a back propagation in the neural networks, at that time they use, back tracking. Correct, sir. Your understanding is correct. Back tracking is when we try to apply our optimizers. Correct, sir. Correct understanding. So, guys, there are like multiple back propagation. Correct, sir. Correct. Back propagation. Correct, back propagation. So there are multiple, like now you try to understand what is the job of this optimizer. Error minimization. Correct, sir. Correct understanding. So this optimizer, where they will come into the picture, try to understand now. Optimizers, the job of the optimizers. So optimizer, what happens is like this, let's imagine this way. So this is our neural network. This is our neural network, and in the neural network, you guys always know that there are two operations happening. One is forward propagation, one is back propagation. Well, now let me change the color. What happens is I pass my input here. This is input layer. I pass my inputs like this one, x1, x2, x3, and this hidden layer, this will perform two operations like I told you yesterday. Step 1 and step 2 operations. In step 1, they are doing the summation of the inputs multiplied by weights. Summation of input multiplied by weights, which is called as Y. y, and y will be like this one, y equal to summation of x into w, xi into wi. Okay, and then what happens is in step 2, in step 2 entire things, this y goes through the activation function, activation of this, and then on the basis of this activation function it will decide whether to pass this information or not, and then try to bring that information in the scale of 0 to 1, -1 to 1, another this operation. Okay, so these two operation happens here, and this once these two operation happens, okay, these two operations happening in the hidden layer, then what happens is, try to understand here. So then what happens is, this is how they are connected to each other, and let me draw very quickly this thing, and here is my output, my prediction y hat, and here is my inputs are going. Let's imagine very simple input. I have taken x1, x2, x3. This is my input layer. These are my hidden layer 1. This is my hidden layer 2. And these operations are happening out here. And then I get my prediction. Okay. Let's imagine, sir. Let's imagine this way. Activation function decide information to be passed further stage or not. Yes, sir. There are three operations actually. Activation function will do. First to activate the neuron or not, then try to bring the data in the scale of 0 to 1, -1 to 1, or from minus negative scale to 0 to like plus infinity scale, 0 to infinity scale, plus infinity scale. Okay, this three transformation it does, then it does the activate the particular neuron or not, and third thing, it brings the non-linearity in the function, non-linearity, like when the data will not be able to fit like equal to y equal to mx plus, this kind of a data is not there, then it will become a non-linearity. So this activation function does, and then we get our y hat. Let's imagine whatever model we have created, three transformation. Yes, correct, sir. Three transformation it will do. So, sir, imagine that we are trying to predict a BMI. Imagine. So, what is the BMI for Vikas? So let's imagine my actual BMI is 30, and this model gave my prediction as 35. Now, what is the problem? There is a loss, actual y hat minus y actual. So what is my actual? 30, and prediction is 35. Means there is a loss of 5. So now I have to reduce this loss. I have to bring this loss to 0. Bring this. Then my optimizer comes into the picture. Okay. Then optimizer starts working. Optimizer starts working. Now let me tell you very quickly what is optimizer. What optimizer will do, there is something called as this kind of a thing is there. We have seen, I think, this diagram. In the bottom, there is something called as global minima. Global minima, where it is the 0 point. Now try to understand what I have to achieve here. So there will be three such things will be there. One, here will be weight, here will be biases, and here will be error. So I have to reduce this error to 0 point. This 0 point, and I have to choose the value of weights and biases, because my equation is like this one, y equal to wx plus b, right? So I have inputs x with me. I have to only choose the value of w and b in such a way that my error is getting to the zero level. So that is what my optimizer does. So this is a very, very famous diagram of the gradient descent algorithm, which uses this descent algorithm, this one, to find out the value of W and B. Now, in CNN, I have to find the value of W and B also, but I have to find the value of filters also, exact filter values, right? So for that purpose, I have to calculate these things. So they will be starting from here, then they will go here, and they will try to reach to the exact value, such value of weight and such value of biases, so that the error here on the third dimension, error will be 0. So such combination they are trying to find out. That is the job of the optimizers. So there are different optimizer and they work in a different ways. Okay, they work in a different ways. And the very famous optimizer, Adam optimizer, what they do is they try to take the time estimation into the consideration. Time estimation, time points consideration. Like they will try to create like this one. They will try to find out what is the momentum at the time t0, t1, or t minus 1. And on the basis of this different things, what is happening actually at time t, time 0, time v. So what they decide is like, let me rub these things and tell you. Reaching to 0, such optimizer necessary. Yes, sir, correct. So reach to 0, this optimizer will work. This will work to find out this value of weights and biases and the value of kernels, so that our our error will become close to 0. It will cannot be 0. Try to remember, guys, in machine learning, we cannot reach to 0. We are reaching close to 0. Exact 0 is not possible. If we reach to the exact 0, what will happen? my accuracy will be 100%, which is wrong. Which is wrong. In machine learning, which is wrong, which is data science AI, it is wrong. Only God can predict 100%. No one else can predict 100%, right? So that is wrong thing. That's why we try to reach. That's why I'm writing this sign close, approximate to zero, approximate to zero, not exact zero. That's what I'm writing. Okay. So that's what it does. Okay. This is all the entire story. Now I was talking about Adam. Adam, what does is it try to give the weightages. We try to give the weightages to the time points. Means try to understand. Imagine this is time t equal to 0, this is time equal to 1, this is time equal to t, and this is my output x1, x2, x3. So okay, so absolutely only God's 100% accuracy. Correct, sir. Correct. Okay. So try to understand Adam, what Adam is doing. So what I'm doing is when I'm predicting at time equal to 3. Sir, please try to concentrate everyone. So very important concept, Adam. So time estimation. Why it is called as momentum estimation with the momentum, adaptive momentum estimation, momentum. So when I'm trying to predict at time equal to 3, obviously the time equal to 3, output at time equal to 3 will depend on more on time equal to 2, right? Time equal to 2 is my recent output, and then time equal to 3 is my not that recent, and T0 is not my that recent, right? So what I do is for whatever T3 I am predicting, I'm giving the latest time point. This time point more weightages like this one. I give more weightage like 0.45. And for time T1, which is not that recent, I'll give less weightages like this one, 0.2. And then for T0, I'm giving less weightages, even more than that, like 0.01. And then I'm multiplying this by inputs. This plus x2 into this plus x3 into this. Means by doing this, what I'm trying to do, I'm giving more weightages to my latest time point, and less weightages to the previous time points. And then I'm doing my prediction. Okay. So this kind of a things is called as momentum estimation. Momentum estimation. That is called as adaptive momentum estimation. So we can have a stochastic gradient descent with momentum also, with momentum. So this kind of a things is very important, because when we try to deal with the time series data, when we try to deal with the latest data, we have to give more important information to the time, because whatever the latest time stamp is there, it is very important rather than the previous time stamp and the previous time stamp. For that, I give more weightages to the current time and less weightages to all other previous times. So that kind of estimation is called as adaptive moment estimation. That is called as momentum. And by using momentum, these guys optimizers, they are trying to reduce the loss. All right. All right. Okay, sir. Thank you. I think you know. Okay, sir. Thank you very much for this kind of a confirmation. So hope now everyone is able to understand now what is optimizer, what is loss function. Loss function always try to create only this value, predicted value minus actual value. That is the loss. And this is for 1 point, when we calculate for 1 point. And when I sum a loss for all the data points, it is called as cost function. So loss is only for one data point. When I calculate for all the data points, it become a cost function. So that is why we have a different cost function. For regression, we will have, for binary class, we have different. For the multi-class classification, we have different loss functions. That's why. All right. So everyone now, I think, understood everything clearly. What are the things, how we are doing this kind of a things. Now guys, I will give you one code, like I will share with you. Now it is a job for you guys to practice. So I'll show you this code, and this is the same thing, like I will explain you. Now you can build your own one customized model. Okay. You can build your customized model for your own face detection. And let's do this thing now. All right. Let's do this thing. So let me hide this meeting. Now there is a one code I've created here, guys. Try to see here. I am using here. I will use this one. I'll tell you what model I'm using. I'm talking about VGG16. Remember this model I talked about. So I'm talking about VGG16 model. All right, guys. My colleague Chandana has pasted the feedback and attendance link. If you guys can go through it and you try to check the link and try to give a feedback and the attendance, okay, accordingly. So it is a link is shared, guys. You can refer to the chat box. All right, guys. Now what I'm trying to achieve here, try to understand here. We are using one pre-trained model, VGG, Visual Geometry Group 16. This 16 means it has a 16 layers. 16 layer. Okay, this kind of a model is there. This model is pre-trained, guys. This is a pre-trained model. Now we are downloading that model here. I'll show you how to download that model, and we'll freeze the weights. We'll freeze the weights for this model because I don't want to retrain this model. I don't want to retrain this model. I'm going to customize. I'm going to customize this model by my own data, and try to create a kind of a face detector. Face detector. Very quickly, I will give you a code walkthrough. It is a guys, your homework, you can say. You try to plug and play with this transfer learning. This is also called as transfer learning. Transfer learning is I am sure you guys are like heard these terms various times, right? So what is transfer learning? Transfer learning means there is a model which is pre-trained. You are already using that knowledge and you are trying to customize that for your own purpose. Okay. Yes, guys, I will sharing this code immediately with you guys. So you can like plug and play with this code. Okay, I will share this code with you guys. So don't worry. I will try to download this file and I will share it here only. And at the end, I will share these things. Okay. So guys, try to understand this code now. What you have to achieve? Like I told you, this is a pre-trained model. You guys have heard this concept transfer learning. Transfer learning means what? Try to understand here. Transfer learning means the model is already pre-trained. It is tried to do the things. Okay, as per the customization, whatever data and whatever classes it is trained, right? Then what you have to do is you have to take that model, you have to freeze that model. Okay, freeze that model, and you have to unfreeze some layers, and you have to train your own data, and then you have to use it for own case. That is called as transfer learning. Is local laptop capable? No, 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 ma'am. Local laptop is not capable. You have to run on Google Colab. Okay. Okay, sir, you have to run on your Colab only, these notebooks. So very simple, you can like go to Google Colab and run these things. Not possible in local laptop because if you have like a GPU on your laptop, then only possible to run these things. Okay. So guys, you have to do this transfer learning. Try to understand what you have to do. Like I will explain you the code, and then I will explain you like where to pass the data and everything, and you can plug and play with this code. Okay. So guys, what we want is like same thing. We are using the Keras and TensorFlow only. So, but try to understand. I'm downloading one model here actually, which is 16 model. Okay. So I am first importing the layers, Keras.layers, input layer, then lambda, dense layer, and flatten. Don't worry, these are just layers. And then I am importing my model, like sequential model, remember? Then we are importing once VGG model, VGG16. This is a pre-trained model. Okay, VGG16. This is a pre-trained model, and we have to plug and play with this model. That's why I'm importing this from keras.application.vgg16 import VGG16. Then from VGG16 import the pre-processing input. Like we have to pre-process the input also. Then we are importing the image, then image data generator. Like you have to generate the data, you have to create one loader, right? You have to create a node data and pass it. And you guys already know the sequential model. And then we are calling this numpy globe for creating the folder path, and then matplotlib to plot the things. Okay. So this kind of a package I am loading. You just try to load everything as it is. Don't make any changes. Okay. Then you have to create this path, guys. You have to create this folder dataset train and dataset test. And in this folder, like you have to create here two folders you have to create. And in this train and test folder, you have to keep the images. You have to keep the images, whatever images you want to do the face detection. Let's imagine I want to create a face detection for 5 people. So within train and test, like we created dog and cat, like guys, you have to create 5 folders if you want to create for 5 people. And for 5 people, at least try to keep 100 pictures each. 100 pictures each. Okay. So create these folders, training path and validation path I am writing. Try to write the image size. Whatever image you are going to use, try to write the size of that image here. Okay. Here I am using 224, 224. You can check the image, whatever image size you have. Try to bring them to the same image. Like there are online application also where you upload all your image in one goal, and you like click one button. It will try to resize them into the one image only, one image size. Okay. That kind of application available on Google. Okay. So resize them, all the images. Let's imagine you are doing 5 people's face detection. So you at least use at least 100 picture one person. So 500 images you can use, and try to keep them in the name folder. Like you are using, let's imagine this way. If you are using the Abhay Kumar sirs, and then Sneha Kumar sir, Sneha Kumar Shalini sir, and then sir or ma'am, and then let's use Vikas, and let's use Amar, and let's use like one more thing, let's use what you can give a name, anyone like Chandana. Okay, let's take example, and then try to create this number of folders, and within this folder keep the images of that respective people. Okay, and then try to save these images in the train and test folder. respectively. Okay. And once you are done, then try to come here. So what is the next thing you have to do? So you have to add a pre-processing layer here. Pre-processing layer. Okay. So pre-processing layer equal to you are just downloading a model. So this model name is VGG. So you write a name variable name VGG. Then you write a VGG16 input shape equal to this size of whatever size of image you are passing. That size we have created. Then plus 3 it is trying to take the model layer plus 3. That's why. And then we have to take the image net weight because this data is trained on the image net data set. That's why that weight equal to image net and equal top equal to false. It could include top equal to false because we are not going to use the same thing. We are going to recustomize them. That's why include top equal to false. Okay, this is how we are writing. So it will download the model. It will download the model. It will store the VGG model there. And once you store, guys, once you store the model, what you have to do is, so since you are passing this data, and then whenever you are running this model, you don't have to train from scratch, right? You have to use already pre-trained weights, and then you have to add your data. That's why. So don't train the existing weights. Okay, keep as it is. That's why you have to add this line for layers in VGG, layers dot trainable equal to false. So what will happen? Whatever this image net weights you have created, that will remain same. Means this image in image net data set is able to identify 10,000 categories. Okay, 10,000 categories. That things will remain same. Only you can add your own categories. Like 5 people, I have told you that 5 categories will be adding here. Then obviously I am creating this folder path here. Data set equal to train the current folder here. And for the length of folder, you can say I kept it 4 files, 4 folders because I have added a 4 people's picture. So you can add your 5 people, 2 people, whatever folders you want, you can create. Okay. By using that, they are checking how many classes are there. Then what you have to do? So you have to write like this one. You have to flatten the output. Whatever training you will create here in the end, you have to flatten that and pass to the dense layer, like last layer, right? Whatever layer information you create, flatten that and pass to the dense layer. That information we are writing here, flattening thing, and then activation function sort max because it's a multi-class classification and whatever length of folder is there means how many classes you have to take, that many classes neuron you have to write right in the last layer, output layer. So how many classes you are taking, that many classes of the neurons you have to create. That's why they're taking the length of the folder plus one, they're additionally doing one, and that's how. So that is how they're doing a predictions. Okay, and then you have to take this model VGG model, which is your input and output equal to prediction means this layers, right? And then you can check the summary here, model.summary. Okay. So you can check the summary that entire 16 layers are here. See here. There are 16 layers are created. These 16 blocks are there. So block 1, block 2, block 3, 16 blocks are there. Plus you are giving your customization. In the end, you have a flatten layer. In the end, you have a output layer. 5 class. You are taking 5 classes. Okay. This out. And these are the total parameters like 1 crore 48 lakhs plus parameters are created. And then guys, you have to compile your model like the same way. Compile model with loss function, categorical cross entropy now. Okay, and then optimizer, I'm taking Adam accuracy matrix. And then you can like pass your training data and test data generators. This is the simple code like you have to write the same way. Image generator recycling, like we remember we do the normalization also in our model. Recycle here, this zoom range and this range, you don't worry about it. It is just trying to take the image sizes and their zooming range and all. It is doing kind of a adjustment and try to normalize the data. So you create a trend generator, test generator, pass your like paths and all, and you have to write this generator that from which library path you are taking, what kind of a mode is categorical. Okay, and the batch size, like how many pictures to be picked up at one size, and what is the target size means whatever the prediction will be done at that time for the training purpose, how you are converting your images, right? So that kind of information you are provided. Then you can see here found 10 images in 5 classes. Like I have taken simple images. Then you try to fit your model with the same thing, training data, test data, and number of epochs. I have taken 5 guys. Don't take 5 epochs. Okay. Okay. Don't take 5 epochs. Try to take more epochs, like 10 epochs, 20 epochs. And that's right. Try to run this code as it is, as it is. Just only change you guys have to do is like how many folders you are creating here. Okay. So this folder path you have to change, and like it will try to take from the folder path like how many classes you have created and just create this folder. That's only change you have to do, and run the same code as it is. Run the same code as it is, and like try to save the image, and now it will try to run for 5 epochs. I am taking 5 epochs, but you try to take more epochs, and then you can check the accuracy also. The accuracy is very very, the accuracy is going 100%, right? Which is wrong. Like which is wrong. I know because I have not taken much more images and I'm not taken like much more epochs, right? So take more epochs and then you can check plot the accuracy also, plot the loss also. this way. So you can plot and you can like do the things, right? Then afterwards try to import the this one, load the model dot save. So whatever model you have created, you can save that model by this name, face feature model, because it is detecting the faces, right? You can save your model also, and you can give this model to anyone to perform the prediction, okay, in the end. But guys, why this is showing like more problem is because I've taken only 10 images or 5 images. You try to take 100 images per category and try to train it for more epochs. I've trained only for 5 epochs, okay? Same code, same everything, just create only separate folders for all the people, whatever faces you want to create, and try to plug and play with this pre-trained model. All right. So guys, everyone I think understood like what kind of a changes you have to do here. What is this entire pre-trained model is all about? Any questions, any doubts, guys, as of now for this one? Hope this only thing you have to change is this path. That's it. This path, or if you are trying to take a different image size, that only thing you have to change. Otherwise, everything will be same out here. You just have to run the things as it is, and then you will be able to achieve this face detector model. Okay. So hope you guys have understood this one. Comfortable? Can you guys like give me confirmation, or let me know if you have any questions or doubt out here. So nothing you have to do, like you have to change only one thing. Okay. All right. So guys, now let's move to the next topic now. Let's move to the next topic now. Try to understand what is this YOLO model. Okay, I know it's like 15 minutes only, but we'll try to at least start with this YOLO model. And then on Monday, like we'll try to finish and start the NLP session. Because last 2 days I want to dedicate for NLP, especially for chat GPT kind of application, how the training happens. And we try to create one chat GPT coding. So today, like I will start with YOLO model. And like in half an hour on Monday, we'll finish this YOLO model and entire code for YOLO. And let me show you like what is YOLO model today, and then what is the working of the YOLO model, and then we can finish this and we can start NLP then. All right. So let me show you the YOLO model. Let me stop sharing this one now. So let me share my second presentation with you guys for the YOLO. So give me one moment. I'll explain you what is YOLO, and I will show you also how the YOLO works, like object detection model. Then we can directly make a code walkthrough. Just give me one moment. Let me open the different presentation now, YOLO presentation. Right, one moment. Okay. All right, guys. Give me confirmation if you are able to see my screen, and then I'll explain you guys what is this we are going to do with YOLO. This guys,
Yes, Vikas, your screen is visible.
okay, thank you. So guys, this YOLO model, this is we'll try to understand what is this YOLO model. Actually, okay, sir. Thank you, Abhay, sir. Okay, this YOLO model, this is the object detection model. Actually, object detection model. So this YOLO model, this is not the single model. Actually, they have an entire family. They have their own family, and this they have their family history also here. They started with like version 1 to version 8, and then after that they have something called a Sam family, their cousin family, Sam. And then from Sam also, Sam has three variations. Sam has three brothers, and then there is one more cousin, is this YOLO family. Okay, this entire family tree is there. So V1, V version 1 to version 8, like there are 8 members in their family. Then they have this cousin Sam, segment anything model. And then they have this one more their cousins, and their you can call them as a Nas. YOLO Nas. This YOLO Nas also have a three brothers, okay, three siblings, you can say. So this has an entire family drama, guys. We'll try to understand this entire family drama. What is this family drama all about, and how the family looks like. And what is the main aim? What we're going to do is we try to customize this model. We try to customize. We download this pre-trained model. This is also a pre-trained model. This entire pre-trained model, we'll try to download them. And once we download, like only guys in 10 line of a code, in 10 line of a code, I will try to customize this model for my own data and for my own classes. Okay, that's what we'll try to do. Now try to understand what customization shall do. So let's take very good example. Like whenever let's imagine you have installed this model on the traffic camera, this web traffic camera, live feed camera on the traffic. And on this is, imagine this is the people, they are walking on the street or someone is riding a bike. And all of sudden some person falls down. What could be the reason? Could be someone get a sunstroke, or someone get a heart stroke, or this person falls down on the road like this one. This person fall down, right? Fall down. What will happen is this model will be able to detect it immediately. This will detect it immediately. This model, this that person has fallen down, and we try to give a information. Give a information. Let's imagine if you want to implement it on a live basis in the some camera, traffic camera. So immediately it will call an ambulance. It will call an ambulance, and will also perform in also inform the police that some person has fallen down on the road. Okay, some person has fallen down. That kind of a live use case we can build out of this. So that kind of a customization I'm going to show you here. So for that purpose, we have to first understand what is this YOLO model, what is this all about, and we try to understand the entire working and architecture of this model. I know I'm not going to spend much more time, but today, since we have still like 12 minutes, in 12 minutes, I'll give you introduction and we'll try to start with the working. And in Monday's lecture, I will try to cover this in half an hour and then we'll start NLP. All right. So try to understand this, guys. What is this YOLO model and what do you mean by YOLO? YOLO also has a long form, guys. YOLO. Right. So let me hide this putting thing. All right. Now, guys, try to understand what is YOLO. YOLO means you only look once. You only look once. This is the name YOLO. Okay. You only look once. So you only look once. This is what is called as YOLO. Now, why you only look once? There is a meaning. There is a meaning out there. Why they're calling this as a you only look once. Okay. You only look once. So try to understand this way. So this is one of the famous model, guys. This is one of the famous model of the artificial intelligence YOLO model series. YOLO model series. This was originally developed by these three people: Joseph Redmond, Ali Faradi, and the Indian guy, the Santosh Diwala. Okay, Diwala. And this was the first model. This was the first model which was at that time. At that time, it was giving very high accuracy for the object detection in real time speed, in real time high speed and high accuracy. That's why this model was very famous at that time. And this works on the framework which is called as PyTorch. PyTorch. This framework is developed by the Meta, which is famously called as Facebook company. Facebook research, AI research company has developed this framework called as PyTorch. Now you guys will be obviously asking me that what is the difference between like whatever model we have seen as of now. We have used the TensorFlow. We have used a TensorFlow and we have used a Keras. Now, and these are developed by the Google, this framework. And by using this framework, we have created our previous code. Now we are using PyTorch. Now, what is the difference? What is the difference between here? So try to understand what happens is in tensors, like in TensorFlow, what they do is they have something called as tf.session. TF.session. TensorFlow 1 is there, TensorFlow 2 is there. In TF1, they used to have a create one session. Session means kind of some kind of an environment they are creating, and within that they are writing the code in their various separate syntaxes. So there, everything you have to assume in a variable. Whatever information you have to take, you have to create a TF dot variable. Then you have to perform a TF dot operations, and by using the operation, you have to create a tensors. Tensors means three-dimensional array. Three-dimensional array. You have to pass these images into the three-dimensional array. Then you have to create a variables. Then you have to perform the operations, TF operations like add operation, multiplication operation. To perform other operation. Some other code has to be written, and which was very very technical thing. This was a very very technical stuff, right? So normal coder will get bored with that. Normal developers. So what they decided, they created one Keras. This is a high-level API. This is called as high-level API. Just like the English sentences, just like we write the English sentences, like that we have to write a code using Python here, and we can develop directly our entire AI architecture. We have seen the sequential model, Then model.add, this kind of English command we are writing, and we are adding layers and we are creating architecture. That kind of a ease has been given. But in PyTorch, you have to understand, in PyTorch, there is some specialty. In PyTorch, what we have to do is we have to compulsory create the class and modules. We have to create one class here, and within that class, we have to create the modules and we have to create the methods. And using that kind of architecture, we have to write a code. You have to write a code and you have to create a models, AI models. Okay, like let it be artificial neural network, let it be CNN, RNN. You have to follow this kind of architecture. That is the difference between the PyTorch and the TensorFlow Keras, guys. Okay, so that is the difference. Now try to understand. This YOLO is using PyTorch in the background. On the basis of that, we are creating one model which is useful for the object detection, and it has a very high accuracy and high speed. Okay. Now, what is this model? This model is also a convolution neural network only. This is a convolution neural network only, but the way they are doing, the way they are creating the architecture is different, guys. Architecture is different. That is why it is called created for the object detection. There is a family like, and what is the beauty? Like this one line is very important for the YOLO, that it is doing one stage detection. One stage detection. It is doing one stage detection. Now I'll explain you like what is one stage detection and what is multi-stage detection. So there are like a famous architecture also along with this YOLO architecture. There is also one architecture which is called as RCNN. RCNN. This RCNN are, I tell you what is RCNN. Region proposal. Something called as region proposal convolution neural network. Convolution neural network. Now you guys will obviously be surprised to know that what is this region proposal convolution neural network. This RCNN, guys, this RCNN also have a family. There is something called as faster RCNN, something called as fast RCNN, and there is a normal RCNN, There are three variants to this one, and YOLO has an entire family like V1 to till V8, and then there is a cousin family SAM, and then their cousin family, one more cousin family was NAS. This NAS, YOLO NAS, and this YOLO NAS has a different model like small, medium, and large. There are three models. Okay, so this comparison, the architecture, the way they're creating the architecture of the convolution neural networks is different, and by on the basis of these different convolution neural network, these guys are doing the object detection. So what is the specialty of YOLO? In one shot, single shot detection, single stage detection, it is performing. And this region proposal, I will explain you guys what is this region proposal. Try to understand this one. What is the region proposal and why they are doing this kind of a things? We'll try to understand this one. Now try to understand. And YOLO, YOLO is called as you only look once. There is a reason why they call as you only look once, because it is trying to do this detection. Let's imagine if you pass this image, to YOLO model, then what will happen? There are three steps process happens. What happens is try to take this image and they try to resize the image first. They first try to resize the image. Okay, they will resize the image first, and they will run through the convolution neural network. They will try to run through the convolution neural network, and once it is go through the convolution neural network, there is a one more algorithm used called as NPS. Sorry, not NPS, NMS. NMS algorithm. We use a NMS algorithm here. NMS algorithm, and this NMS algorithm will finally help us to do the object detection. Okay, so very beautiful concept is there, guys. Very beautiful concept. You should know always like wow, how the YOLO is working. What is this NMS concept? NMS means non-maximal separation, non-max separation or non-maximal separation. Okay, this is the separate algorithm. I'll explain you this algorithm in upcoming session. So what is this NMS algorithm? How it is different? So try to understand. Let me tell you. When we pass this image, what is happening? This image is getting converted into the numbers, into the matrices. Then we try to resize these matrices. Then we pass these matrices to the convolution block, and this convolution block goes to the flattened layer, and then this goes to the artificial neural network layer, this layer, and then in the end we get our prediction, right? So this is what, and in between here they apply this algorithm called as NMS algorithm here for the detection. Okay, this kind of architecture is this one. So this is like this is happening in the one shot. This is a one stage detection. This is called as one stage detection. This entire architecture, because we are taking the image, we are resizing the image. Then we have a convolution blocks out here, and then we have a flattening layer out here, and then this is followed by our artificial neural network, right? This one, artificial neural network, and then we get our predictions y hat. So this is the architecture. Now try to understand what happens is there is something called as, I'll explain you this very quickly. Like there is something called as, try to understand guys. RCNN. We'll try to understand today the basic difference between RCNN and what is the difference between YOLO architecture. And we'll try to conclude our session in next session. Half an hour, I'll explain you entire algorithm, this NMS algorithm and YOLO algorithm, how it works. Okay. Try to understand the basic difference. Let me draw the diagram. Let me explain you. When I pass this image, okay, let's imagine I pass this image to RCNN. What is happening? So in RCNN also, guys, we have this kind of a diagram out here. So first will be convolution block. This convolution block will be there. There could be multiple convolution blocks. Like imagine our way, there will be multiple convolution blocks will be there. Then there is something called as, let me use the different color out here. So then something called as this flattening layer, and that flattening layer will be followed by this artificial neural network, right? This is the normal architecture actually. So guys, what is the problem? This region proposal, okay, RCNN stands for region proposal. CNN, region proposal, convolution neural. Now try to understand when we passing this image out here. Let's imagine when we pass this image to the convolution block. Now what is happening, guys? What is happening? Before detection, there is, let me use one more color out here. So this parallel to this artificial neural network, there is one more artificial neural out here. Let me draw that with a red color so you guys can be able to understand. So they are using like vertically, there will be one more artificial neural network will be there, okay, vertically. So this kind of architecture will be there. This is our normal architecture. This is our normal architecture here. This is our normal architecture, but here what is happening? They introduce one more block out here, which is a artificial neural network only. ANN, one more artificial neural network parallel to this one. This is the first artificial neural network. This is the second artificial neural network. And let me tell you what is happening out here. Let me tell you what is happening here. Okay. So when we pass this kind of artificial neural network second here, so the moment I pass this image, what is happening? It is going through the convolution operation. And once it is go through the convolution operation, guys, then the output of the convolution operation goes to the second artificial neural network, and this goes to the first artificial neural network also. So now you will be wondering that what this second artificial neural network does. I'll tell you. Now try to understand. So when we're doing object detection, guys, let's say and try to understand. Here in the picture, there is a man out here. There is a man. There is a dog out here. There is a horse out here, right? How the object detection happens? When I pass this image, then try to create this kind of a bounding box, rectangle bounding boxes out here, right? Around the image. Means they are trying to identify in the picture where is the actual image, right? These bounding boxes, this is called as bounding box. Bounding boxes, okay? This is called as bounding boxes. These bounding boxes, guys. Yeah, guys, yes, we'll share the link again, okay? All right, I've shared the link, guys, again for the feedback. So, guys, try to understand these bounding boxes, okay? These bounding boxes are created, and these bounding boxes also have a probability. If you see, this is having a probability that, what probability, like this one, 0.8. 0.8 probability that this person is a man. This picture is a man, okay? This kind of a bounding boxes are created. And this is how they're doing object detection. So what happens is this second neural network, guys, this is create these regions. These bounding boxes are called as regions. Region of interest. It is something called as ROI. Region of interest, ROI. So this second neural network, when we try to convolute the image, when I'm taking this image, trying to convert them into the matrices, and these multiple matrices are created here, right? Here, multiple matrices created. That multiple matrices goes to this second neural network and goes to this first neural network also. What will happen in first neural network? It will try to learn the features here. It will try to run the features in the first neural network. But in second neural network here, let me write it with a different color now. So in second neural network, it is creating the ROIs, region of interest, like this one. How to find out these boxes? how to find out these boxes. And for these boxes, this imagine these ROI boxes, they will create something called as height. What should be the height? What should be the width of this box? Okay, what should be the width of this box, and what should be the center point X and Y of these boxes. This kind of information is predicted here in the second neural network, and in the first neural network it is trying to learn the feature. And then once it is able to understand this ROI, once this it is able to understand ROI, the same information again goes to the second neural network, the first neural network. Then guys, then combine it. I think this is a mess. I'll again try to create this diagram again. Okay, so this image is getting passed. This image goes to the convolution block here. Convolution block. Okay, this convolution block has this pulling, padding operation, all this operation. Out of this convolution operation, there will be multiple matrices created. This multiple matrices created. This goes to two artificial neural networks here, because this is a two-stage detection out here. Because try to understand what is happening here. Let me show you this diagram and we'll try to conclude our session here. And there will be one more artificial neural network will be here. Okay. So let me quickly draw this diagram. And this is the artificial neural network 1. This is artificial neural network 2. Okay. So what happens is when I pass this image, it try to convolute. And after convolution, it is creating the kernels, filters, matrices. This matrices also goes, let me draw this with a different color now. So this goes here also to first one, this first artificial neural network, and this goes simultaneous to second artificial neural network. Now, what is the job? The first artificial neural network, ANN, is create a ROIs, region of interest. What is these ROIs? These ROIs are these boxes. This is called as bounding boxes. Bounding boxes. Okay. So this bounding box information of the height, the width, and the center point they create, and this will give us this information of ROI. This ROI information also goes here to second one, and these features also goes, and then the final prediction comes, guys. Then the final prediction comes. So this is the entire architecture, and this is what the prediction comes in. You will have this kind of a bounding box, and you will have a probability also. You will have a probability above that. You can see the probability out here. What is the probability that it is a dog, this is a man, this is a horse? Okay. So this kind of a things happen. This two-stage detection. This is a two-stage detection, and this two-stage detection is called as RCNN. RCNN neural network. Okay, that is why it is called as two-stage detection. But in YOLO, we have a single stage. Like this image get passed to this convolution. This convolution then it resizes. Then it is goes to this same thing, flattening layer. But there will be no such diagram. No such diagram. It will directly create these regions. It will directly create the region. It will directly create the proposal there, right? So everyone, I think now everyone understood what is two-stage detection, what is one-stage detection. YOLO is doing one-stage detection. It is using the separate algorithm. That algorithm name is NMS algorithm, and then it is trying to do a object detection. So that is a two-stage architecture, two-tier architecture, one-tier architecture. That is the basic difference between RCNN and the YOLO, guys. All right. So we'll try to conclude here. I know it is 5 minutes late. So I guess everyone now today enjoyed this entire session. You guys are able to understand what is this YOLO, at least some introduction part. And then we'll try to understand this, guys. NMS works for finding ROI and prediction. Yes, sir, correct. NMS will try to help us to find out the exact final bounding boxes. So what are my, there will be thousands of bounding boxes which will be found out. Out of that, NMS will try to find out which are my final bounding boxes, which are the three final boxes which will give me the actual object, like this one, man, dog, and horse. That is the job of the NMS algorithm. All right. So guys, so we'll try to conclude our session today. I know it's 5 minutes late still. So I guess, but you guys have enjoyed this entire session. Very fruitful session today. We will able to understand the entire pre-trained modeling. We will able to create our own architecture, and we also have started with the object detection introduction. What is YOLO? Why it is one stage? Why other things are two stage? What is the RCNN algorithm? And what are the pre-trained algorithm? How you can download and customize this, right? So to next session in half an hour, we'll try to finish this YOLO and we'll start with the NLP topics. All right, guys. So I think you guys have found it very fruitful session. So thank you very much, guys, for your cooperation. Thank you. And I will wish you a happy weekend and see you on Monday again, right? See you on Monday directly on for the next session. Thank you very much, guys. Thank you very much once again.
Yeah, thank you, Vikas, for a wonderful concept. And hope you guys enjoy the session. Is there any queries for me? Please let me know in the chat box. And one note, important note is there. And tomorrow and after tomorrow is a weekend, so we don't have a classes. So we'll meet on Monday again. Okay. Tomorrow there is no class. Saturday, Sunday. Yeah, the codes we'll share in LMS. Please get from there.
Okay, course, yeah. Okay, okay. Yes, I will send it across. I will send it across, guys, immediately in some time. I send it to the team, and then team will upload it in LMS. You can take it from the Schoolab link and all. All right.
Yeah, yes, because we will upload in LMS. So no need to worry. So is there any queries for me, or else we'll wind up the session for today? Attendance link. Yes, I'm sharing. YouTube people don't have any queries. So here also there is no queries. So we'll wind up the session for today. Thanks for joining and happy weekend. Up to then, be hydrated and be careful.